Hello. This is an introduction to http4k library for Kotlin, which provides a nice functional API for HTTP with the emphasis on simple design and testability, so you can actually test drive your HTTP server, client, or whatever else you're doing. And to illustrate http4k, I'll write a prototype of a simple web server, which will simulate board from the tic-tac-toe game, also known as Nuts and Crosses. Here is hello world in Kotlin, and if I run it, it prints hello world. Before we write the server for the game, let's write a simpler server with hello world functionality. To do that in http4k, we need to define an HttpHandler, which is a function that takes a request and returns a response, where both request and response are immutable. Here we have response with status OK, and we want to have body which says hello world. Because HttpHandler is really just a function, we need to ask http4k to plug it into an actual web server. Here I'll use Apache server on port 8080, but there is no particular reason for that, and HttpH4k supports integration with other Java web servers as well. We can see now that the program doesn't terminate, and this is because there is a web server running in the background and waiting for requests. We can manually test it by going to terminal and running a command like this one. We can see that there was a request from curl, then there was a response from server, and the response was hello. This is all good, but it would be nice to do the same thing from Kotlin. We can do that by defining an HTTP client like that. It's also going to be an HttpHandler, and I'll use OKHTTP library integration here. To do the request, all we need is to pass request object to the HTTP client. And we also need to specify URL, which is localhost 8080. What we get back is a response, which we can just print. And we expect output similar to what we've seen with curl. So we get back hello world, we get some headers, and 200 status. The important thing here is that both HTTP client and HttpHandler, so both server and client, they have exactly the same type signature. So they're both HTTP handlers, they both receive a request and return response. This might look like a simple thing, but this is a very powerful simplicity. One thing which is very useful is that client and server are interchangeable, so whenever we do a request to a remote client, we can replace client of the server with the in-memory implementation of that third-party server or with a fake server. So that can be really useful. The other thing is that not overcomplicating lifecycle of your server or not using any magic, that's really useful. And yet another thing is that HTTP handlers are easy to compose. What we have here right now is an HTTP handler, and it doesn't have any idea about routing, it just always says hello. Let's add routing, and we can do this using routes function from HttpH4k core module, which has a small DSL, so we can say hello bind get to, and then I'll paste the same handler that we had before. So essentially, routes function is now a composite of multiple HTTP handlers. If we run this, we should get 404 because we are only handling /hello. So we get 404. Of course, this is easy to fix by just changing the request to hello. And it also would be nice maybe to specify a name, so our greeting is a bit more custom. We can define name as a local variable, and we can extract here query from the request using query function. So now we should expect output saying hello Bob, and it should be 200. So it's hello Bob, and it's 200. There is a question, what happens if we forget to specify the name? And the answer is that we should see message hello null because the type of the name is a nullable string. There are a few ways around it, but the most straightforward one is to just throw an exception here. You can say name is required. At this point, we should expect 500. So So we get 500 and a stack trace. To be clear what's going on, we are just throwing an exception from our server as a function, from our HTTP handler. And then the server is caching it for us and returning 500 and printing stack trace. It would be nice to handle our exception ourselves. And we can do it by defining a filter. Filter is the second most important concept in http4k after HttpHandler. So filter is a function which takes a handler and returns a handler. This is the simplest filter we can write, identity function. To make it a bit more interesting, let's define a wrapper handler here, which is going to be an HTTP handler that takes a request and passes the request to the original handler. This is still not doing anything useful, but we can now wrap this expression with try-catch block, and in case of exception, we can return response, let's say, with status I'm a teapot. The important thing here is that filter has access to request before it's passed to the handler, and it has access to response on the way out from the handler. So we can modify both request and response, so for example, print them. Let's plug this filter into our server. We can say with filter, filter. Maybe we should rename it to catch all. So if I run this now, we should expect output with I'm a teapot status. That's exactly what we get. There are few built-in servers, built-in filters, which come with HttpFK core module. One of them is print request and response. Can be useful, so let's import them, and we can chain this filter with our catch-all filter. These filters will be now applied one after another, and we can define this as filters. The interesting thing here is that if we look at the actual type of the filters, it's still singular filter. And this happens because filter is just a function, and combining filters is just function composition. So it's not a list of filters, it's still just a filter. Let's plug these filters in our server. Another thing is that there is built-in catch-all server filter. Let's use this one instead of our own catch-all. And that's it for advanced hello world with HttpFK. So the main concepts are HttpHandler and filters. There is no lifecycle to know about. There is no special annotations, nothing like that. So all you need to know is HttpHandler and filter. Before we move on to implementation of the server for the game, let's do a quick cleanup. I'll inline filters. I'll also delete the client. And we can extract all these lines into a new backend function. Then inline HttpHandler. So main function is now just a one-liner, quite simple. Then this can be inlined, and newBackend can be public. That's basically the whole cleanup. To write the functionality of the server, let's do test first, finally. I'll switch to a different file and create backend tests class. The simplest test I can think of is a state of an empty game. We don't really have game yet, but we have backend, so let's use that. So I'll move backend into field, make it private, and we can now just use backend in our test. Since we want to see the state of the game, this probably should be get request. Then, since it's a game, probably /game is a good URL. Then we expect OK status of the response. Let's create this as an extension function which will assert on the status of the response. What we're saying is that the status should be OK, and then we can return the response. So we can extract it in the test and assert on the body of the response. I'm not exactly sure what the output should be, so I'll keep it as game.json. Let's run this and see how the test fails. It fails on the GET request, which is somewhat expected because we are not handling /game at all. Let's fix that. I'll delete all this code, and we are not using request. so it also can be deleted. Now we moved on to the next line where we assert on the body of the response. This also makes sense because we're not returning any body here. What we want is probably something like this, game, and then we want to convert it to JSON. We don't have game and we don't have JSON conversion. Let's do it one step at a time and use toString first. To define the game, we can create a data class called game, which will contain moves as a list of moves. These are going to be all the moves that happened in the game. Initially, it's going to be an empty list, and the move is going to be also a data class with x as int and y as int, which are coordinates of the move on 3x3 grid. And it will have a player who made the move, where player is going to be enum with x and o values. Let's run this and see how it fails. We still get failure on the same line, but now we can see that we got toString output, so game is converted to toString. At this point, nothing stops us from defining this function to JSON. However, there is a bit more idiomatic way to do it in HttpK using lenses. To use lenses, we need to define one using syntax like this one. It's going to be lens on the body, and we'll use autoLens on the game object. Then we'll need import of this auto function, which comes from JSON module of HttpK. Essentially what it means is that HttpK will use JSON to serialize and deserialize game from and to JSON. And it will automatically get inputted into the body of the request. Lens is just an object which encapsulates getter and setter functionality. In this case, we want setter functionality, which is called inject. We are injecting game into our target, which is response with status OK. That's all we really need to do here. We are getting different failure now with actual output, which looks like a legitimate JSON to me. I'll copy it into the assertion and just run the test again. The test passes, so we can move on to the next test, which is going to be players take turns on each move. Now we probably want to actually make some changes in the game state. To do that, we probably want a post request, which can also go to the game URL, and we can specify x and y coordinates of the move. We also expect this status to be OK. To be clear, the idea is that the backend will decide who is the player who made the move, and after each move, the players will change. Let's make a few more moves here. Just to have some variety, let's have 2, 1, and 1, 1, maybe 2, 0. Then, after we made all these moves, we want to assert that the state of the game has changed. I don't want to try and type JSON, so I'll do game with some moves JSON. Let's run this and see what happens. This fails on the post. This is because we are only binding get method to the game. We also need to specify binding for the post here. That's one step. Let's run tests again and see what fails. This time we get a failure on the responses body. This is because we're still getting a game with no moves, because we are not modifying state of the backend, because we don't even have any state. This is the point when we should probably introduce some state. So I'll extract game as a val and move it outside of fruits. So essentially, newBackend is now an object and game is a field inside that object. When we post, we want to modify game. Probably we want something like this. We want to call makeMove function on the game with x and y coordinates. This will give us a new instance of the game. then we can update the game field. We don't have X and Y yet, we don't have makeMove. Maybe let's comment this out for now and try get X and Y from the request. One way to do this would be to use the query function, which we have seen before. We are going to get nullable string, and then we can say toInt. That's going to work. However, we could use lenses again, which is going to be something like this, going to look something like that. So it's going to be lens on the query of type int, and it's going to be required with the name x. Then we can have a similar lens for y. Because this time we want to use getter functionality of the lens, we can use function called extract. And it just takes a request and gives us back x, where x is going to be of type int already. We can do the same thing with y, of course. At this point, we have both x and y, so let's comment out the code, and I'll create this function as a member of the game. This might be a good point to pause and think about what we're doing before we dive into makeMove. If we look at the tests, we're essentially test driving our domain object, which is a game, via HTTP API of the backend. This is not ideal, and in the real world it would be a good moment to pause and write tests for the game and test drive the functionality of the makeMove function from here. But because this is not the point of the demo, I'll cheat a bit and I'll just paste the code which I prepared in advance. Essentially what we want here, what we have now is we added a winner field to the game. Every time game is constructed, we figure out if there is already a winner. And if there is one, we return in this player by trying all possible winning moves for each player. If there is no winner, it's null. And in the case that we do have the winner, we don't modify game in the move and just return in game as it is. If there was no winner, we try and figure out the next player and add a new move to all the moves of the game. There is no validation, it's just basic functionality. But let's try it and see what happens. We get now two failures. The first assertion is failing because we added winner field to the game and representation as a JSON has changed. This looks small enough to me, so I'll copy it back into the assertion. The second failure, however, is a bit longer. We could copy it, of course, but it's also a good opportunity to maybe use gameLens once again. We can use getter functionality of the lens and to extract game from the response. What we get in back is a game object, and we can now use our domain classes to write the assertion. We had move at 0, 1, and this is going to be player X. Then we had a couple more moves, player O, also at coordinate 2, 0, and 1, 1 move, which is also X. Let's run the tests and see if they pass now. They do pass, and there are a couple things which we could improve in our backend. One thing which I would do is to extract game as a parameter to the backend, so that when we construct the backend, we can specify the game with a particular state. So if we choose to, we can test how backend works with the game which already contains some moves. That's one thing, and the other is that our game is updated in the handlers. However, we have no guarantees about which thread is going to be calling our handler. HttpK is quite simple. It makes everything HttpHandler, but it plugs it into a real-world web server which has its own thread policy and so on. Because we cannot guarantee this, we need to make it thread safe. Ideally, this code should be a separate concern. It should be separated from HTTP logic and so on. But as a reminder for ourselves, I'll use AtomicReference here for now, so that we don't forget that this problem exists in this code. Use AtomicReference, then we need to use get here. For update, we can use update and get function on the game. It's going to look something like that. Let's run the tests and see if they work. so the test pass, and that's pretty much it for the simple backend prototype. Might be a good moment to move on to the front end. And the front end is also going to be HttpHandler, so I'll copy this code and just rename it to Frontend. Frontend will need to talk to the backend. That's why we probably should define backend as a parameter to the frontend, and it will be passed as an HTTP handler. Then frontend is also going to need some routines. I'll copy this bit. This is going to be, for simplicity, just /root, and then we can say response, and let's return some HTML. This is the signature of the front end. Let's create it in the main function just to see how it goes. What we want here is a reference to backend. However, in the real world, we would run these two processes in separate JVMs. So we could pass reference to newBackend, but because we want to run them in separate JVMs in the future, let's define a client for the backend, which is going to be a backend client. I'll use OK HTTP again. Then we can just pass it as a backend client. Then we also want to plug our front end into the server. There is one thing here, is that we want our backend client to always, we want to use this filter on the backend client so that we don't need to specify absolute URLs in the front end when we want to talk to the backend. We can do it like this by specifying URI of, and then this should be URI of our backend, which is going to be localhost, and let's say 1234, which is going to be a new port for the backend. So that's how we can plug things together in the main function. To write the functionality of the front end, let's write a few more tests. They're going to be somewhat similar to the backend. I'll define a class called frontend tests, and it's going to have a similar test state of an empty game. To create the front end, all we need is to just call the function. Don't need any dependency injection, nothing like that. So just functions calling functions. We can extract this as a field, make it private. Then when we get in the state of the game, it's definitely get request. It's probably going to slash. Then we want a case status, which gives us back a response. And this time, let's do something slightly different. And we can use an extension for JUnit, which will let us do approval testing. This extension called approval test. And it's a part of http4k testing module. What it gives us is that we can now specify approver parameter in our test, and we can ask approver to use approval testing on our response. And let's run this and see what happens. Get the failure on line 14 with the message that no approved content found. The reason is that what happened, the failing test created this file named after the test and after the class and the test name with the extension .actual. If we look at this file, we can see the output which we produce in the front end. If we're happy with this output, we can rename this file to .approved, and this should make the test pass. Essentially, we're telling the test that we manually checked the content and we're happy with it, so the test passes now. Of course, this is not what we want. We want to render actual HTML here. HttpFK integrates with few rendering engines. I'll use handlebars, so we can define HTML renderer, and then we can say handlebars, templates, hot reload, and the current directory src test. Then we should be able to just use invoke on the renderer and pass it, let's say, game view, which is going to be a view representation of the game. We can define this class here, which needs to implement view model tagging interface. This will compile, and if we run it, HTML renderer will search for gameview.hbs file and will render HTML from .hbs file using gameview object as the context for rendering. However, we don't want to just render an HTML, we want to get some data from the backend. To do that, we can simply call the backend. Since we get in the state of the game, that's /game, and because we want the game here, we can use gameLens once again. We want to extract game, that's basically all we want, and this gives us game of already deserialized game with type game. Because we have game, we can convert it to GameView. Once again, because this is not essential for this demo, I'll cheat a bit and paste the code which I prepared in advance. So GameView is going to have rows which are going to be two nested lists with a cell view, and GameView will contain winner as a nullable string. Then the cell view will have coordinates and the player, and this will be the conversion from game to GameView. There is one more thing that we need, which is to create the HBS file. It's going to be GameView HBS. And once again, I'll paste some code which is going to work with the GameView object. So we go through all the rows, inside the row through each cell. If there was a player who made the move, we print the player. Otherwise, we print the URL, which will let us make the move. And at the end, we output the winner if there is one. That's pretty much it. Let's run the tests again. I would expect the test to fail because we just changed the content of the approved file. We now get a different error message saying that there was a mismatch between approved and actual file. If we look now, we have both .approved and .actual file. We can diff them. On the left-hand side, we have .actual file, and on the right-hand side, we have approved file. What we see on the left looks like a reasonable rendering for an empty game. So I'll go ahead and approve it. What we need is to delete approved file and rename .actual to .approved. Of course, this can be automated, and there are tools to do it. I'm doing it slowly so that it makes sense. Now all the tests pass, and this is good, but it would be nice to finally look at our front end. It's always a good idea to see how things actually work. So I started the server now. We can go to the browser and look at this page. So we can see the grid now. And if I click on one of the cells, it takes us to an empty page with the URL /move. So this is the last thing that we need to implement. To do that, let's write one more test, which is going to be, again, players take turns on each move. We want something similar to what we did with the backend. I'll copy this code. We don't want backend though, we want frontend. Then we want a get request. It was called move, and just for variety, I used paths to pass X and Y. The last request should give us a response. And we can once again use approver to approve the content of the response. We can say approver assert approved response. Let's run the test and see how it fails. It fails on the request, which makes sense because we are not handling /move here yet. Let's do that. We can just return OK status for now. And because we want to extract X and Y from the path, we can also use functionality of http4k to use curly braces in the path, so that when we have a request object, we can use path function and specify X and Y as names. That should give us X and Y. Then what we want is to update the state of the backend. So we want to call backend. This time we want to post, and we want to post to the /game, specifying x and y coordinates. So we are just passing them through. For simplicity, let's ignore the response from the backend. And at the end, what we want is to render the state of the game, which is essentially calling this endpoint on line 27. The most HTML idiomatic way would be to use the see_other status and specify header, location, and use /. Let's run this and see what happens. It should be X. We still get failure on line 18, and it says that we expected 200 but got see_other. The reason is that our front end is not following redirects, which we can fix using the client filter, which is part of HttpFK core module, client filter called follow redirects, which will wrap our front end. If we run this, we should move on to another failure. Now we're moving on to the approval test, and because approval test doesn't exist yet, let's check the output manually first, and I'll run the main function once again. Let's go to the browser, refresh the page. If I click now, we can see that the backend decides who's the next player. If I click here, X wins. Clicking on empty cells doesn't modify the game once we have the winner. Of course, this is just a prototype, because even to start a new game, I need to restart the whole server. Let's maybe try this time and help O win instead. So O wins, that's good. And there is one more case, which is to have a draw, which can be tricky sometimes. Oh, I guess, yeah, O has to win anyway. What we have seen is just a subset of HttpFK features. It has integration with more client servers, JSON, XML libraries, and template engines. And I didn't even mention serverless platforms. We've seen some approval tests, which is a big topic on its own, but HttpFK can also help with contract tests by making it easier to write fakes for third-party services. It can also help with chaos testing and to record and replay traffic. If you remember one thing from this, please make sure it's that client and server, they have exactly the same type signature. So they're both HttpHandler, which takes a request, returns a response, and there is a filter wrapping around it. If this was interesting, you can find all this content in this GitHub repository. You can also take a look at the official Hello World project by HttpFK team. And of course, HttpFK itself is an open source project, Apache 2 license, so you can read source code. If we look at the history of HttpFK, you can see that there are two main authors, David Denton and Ivan Sanchez, and they did some public presentations. For example, this one at KotlinConf or this one at Kotlin's conference. There is, of course, HttpFK website with lots of good content, including blog posts. If you have any questions, you can always ask them on Kotlin Slack in the HttpFK channel. This is it. Thank you for watching.